All right, today's lesson is we're actually going to be using some trigonometry, not just setting up the ratios. So the objective, students will be able to find missing sides of the right triangles using trigonometry. So before we do any of this, I just want to make sure we have some of these basics down. The first one shouldn't be a huge deal. We're solving this one for x. It's x divided by 4, so to cancel division, we are multiplying. That will cancel out division, but we have to multiply both sides. If we multiply one side by 4, you have to multiply the other side by 4. So we end up with 40 is equal to x. That one, hopefully you guys should know. If not, hopefully you remember now. Now the second one is a little bit more difficult. And this is where a lot of people messed up because they tried to do it like this one. They just multiply both sides by 20. But we're not taking 20 divided by anything. We have 20 in the numerator. We're dividing by the x. So you actually have to do this step where I multiply both sides by x, just like I multiplied the other one by 4. Oops, can't talk and write at the same time. Now, it doesn't seem like that helps us because it doesn't really get us much closer to getting the x all by itself. However, the thing it does is we don't have it by itself, but now we have something we are familiar with. Now we just divide both sides by 5. We get x is equal to 4. Now, there is a little bit of a shortcut for this one, and I don't know if this is a good math teacher in me or not, but if you ever have one that looks like this, where you have a fraction with the variable in the denominator, you can actually take the denominator and the other side and switch them. So x is equal to 20 over 5, which means x is equal to 4. So again, that's a little bit of a shortcut, and I know some math teachers would say I shouldn't teach that because it's just a little trick. But I mean, it's a trick that works every time, and it's just kind of skipping a couple steps, as you saw the last way I did it. So remember that when we're getting into this. I separated this into 5 steps into solving these. Now, these 5 steps, in my opinion, make it seem a lot more difficult than it actually is. I think 5 steps kind of seem like a lot. I try to keep it to 3 or 4 steps when I do things like this. But I really broke it down to its most basics. So the first step is label the sides that you're working with. Now, I called the sides you're working with, I called them the marked sides. They could be marked with a variable or with a number. Usually in a triangle, 2 of them are marked and 1 of them is not. Step 2, figure out which trig functions you are using. So we're using sine, cosine, or tangent, and again, you're going to use SOHCAHTOA for that. Then step 3, figure out what your ratio or what your fraction is. Again, using SOHCAHTOA. Once you have that, for step 2 and 3, you're going to use that to then fill in your equation. You're going to have to start with your trig function, then your angle, and then it's equal to your fraction. So just for an example, if the trig function is sine, my angle is 30. That's going to be equal to, and then x over 10 or something like that, whatever you get your fraction to be. And lastly, then you're going to solve it. And when you solve it, it's going to be very similar to the way we solved these problems, which is why we started with that. So let's get started with this one. So the very first step, and I used to not teach this step, and I think a lot of students started getting confused with this. The first step is we want to label the sides we're working with. Well, obviously this is the hypotenuse. That's the longest side. But is this side the adjacent or the opposite? Well, that's where it comes down to what we learned before. What angle are we working with? Well, they gave us this angle 64 right here, so that's the angle we're focused on, which means this is the adjacent side and this is the opposite side. But we don't care about the opposite side because we don't know anything or want to know anything from that. We don't know how long it is, and we don't want to know how long it is. If we wanted to, we could use one of these trig functions and figure it out. So those are the 2 sides we're working with and the angle. So we have the adjacent and the hypotenuse. So we have SOHCAHTOA. Which one of those has both the adjacent and the hypotenuse? Well, SO has the hypotenuse but not the adjacent. Tangent has the adjacent but not the hypotenuse. It's got to be CA. So remember, the C means we're dealing cosine. Not only that, but then the first letter is always the numerator. The second letter is always the denominator. So my adjacent over my hypotenuse, well, if you go over here, your adjacent is the x, and your hypotenuse is the 20. So naturally, that brings us to our next step, where we're setting up the cosine of our angle 64 is equal to my fraction x over 20. Now, this is where it's important to realize that the cosine of 64 is just a number. There's no variables in there. It'd be the same thing if I said like 3 times 6 is equal to x over 20. Well, the first thing you do is 3 times 6 is 18. So cosine of 64 is just a number. It's just a decimal. You guys can plug it in your calculator and figure it out, which we'll do in a second. But for this one, to get the x by itself, just like we did at the beginning of this lesson, we're dividing by 20, so I want to multiply both sides by 20. So before we put the cosine of 64 in your calculator, we multiply both sides by 20. And this way, when you type in your calculator, we're going to have 20 multiplied by the cosine of 64. And then from here, it's just a calculator problem. So just type in 20 times the cosine of 64, hit enter. You end up getting x is equal to 8.77. I always go to 2 decimal places. That's usually, unless they tell you otherwise, that's usually a pretty safe amount to go. So that length is 8.77. So same thing with this next one. This is the angle we're working with. So the angles are the sides that we want. This is the opposite. It's across your triangle. This is the adjacent. It's right beside your triangle. So again, if you look at your sine, cosine, tangent, so COTA. COA is the one that has the opposite and the adjacent. It's the only one that doesn't have the hypotenuse, if that helps out. So I know we're going to use tangent. And what's the fraction going to be? Well, it's the opposite over the adjacent. So the opposite is 11. The adjacent is x. So that's going to be 11 over x. And we have the angle we're working with is 34. So now if you look at this one, again, if you look back to the very first one that we did, now all of a sudden we have our x in our denominator, just like this one. So I just took those two and I switched their spots. It's the exact same thing here. The x and the tangent of 34, I'm just going to switch their spots. So my x is equal to 11 over the tangent of 34. Now again, just like the last one, you could do it the long way where I multiply both sides by x. So that cancels, and then divide both sides by the tangent of 34. You could totally do it that way. It's just a little bit quicker if you remember to do it this way. So now in your calculator, again, all you have to do is type in 11 divided by the tangent of 34. And you should know where the sine, cosine, tangent buttons are in your calculator from the last lesson. I got 16.31. And some teachers want you to round to 1 decimal. Some teachers like 2. I like 2 because it's just one more level of accuracy. But that's basically it. I'll give you some other examples, but those are the 2 types of problems where you have x in the denominator or x in the numerator. And again, once you start doing those 5 steps, a couple of steps kind of combine and mesh all into one. So this one's the angle we're dealing with. So we have the opposite and the hypotenuse. So if you look at SOHCAHTOA, that means we're dealing with sine. The ratio is going to be the so it's the opposite over the hypotenuse, so 17 over x, and the angle is 40. So again, I just did about 3 steps, all kind of in one, and wrote it all out. Actually 4 steps, because now I have my equation. Then we're solving this. Well, again, the x is in the denominator, so I switch their spots. X is equal to 17 over the sine of 40. Put that in your calculator, 17 divided by the sine of 40. I am getting 26.45. Now, if you're doing this exact same thing and typing in exactly how I'm typing this in your calculator and you're getting the wrong answer, make sure you're in degree mode. So on your calculator, click somewhere. It should have a button that says mode. And then you should be able to scroll up or down until there's one that has a radian and a degree. You want to make sure it's in degree mode. So we have my angle right here. So we have my opposite and my adjacent. Now I will say, as much as I like to skip steps and combine and try to save a little bit of time, I still always label what angles or what sides we have, because that one of the really common mistakes is a lot of people will say, oh, so I'm using sine for this one. Well, no, we have the opposite and the adjacent, so hopefully you realize it's the tangent. And so that's why I think it helps to label those. So we have the tangent, what we're using. We have the opposite over the adjacent. So again, it might actually even help to put TOA. So we know the opposite over the adjacent, numerator and denominator. So that's opposite is x over the adjacent 14, and it is tangent of 54. And again, make sure it's equal to. Make sure you don't forget that equal to in there when we're solving. This one, similar to the first one, we just want to get rid of that denominator, so I multiply both sides by 14. So 14 times the tangent of 54 is 19.27. Here's the angle we're working with, so we have the opposite and the adjacent. So we just did one similar to this. This is another tangent. Tangent of 25 is equal to the opposite over the adjacent. So similar to the last one, multiply both sides by 10. So those cancel. We end up with 10 times the tangent, 25. Let's type that in. 10 times the tangent of 25, 4.66. So we end up getting that x to be. So go ahead and do these next couple ones on your own. So I would say pause the video, do the next 3 on your own, then come back and make sure you have the right answers. So this is the angle, so we have the adjacent and the hypotenuse, so we're using cosine of 44. Now the fraction, so COA means we have the adjacent over the hypotenuse. So the numerator is x, the denominator is 14. Just like the last couple we've done, multiply the bottom side, or sorry, multiply both sides by 14. 14 times the cosine of 44 is 10.07. And again, this is another you do problem, so hopefully you're waiting and doing this on your own before you see me do it. So I have our opposite and my adjacent, so we're doing tangent. My opposite is 7, my adjacent is x, and again, I'm kind of combining steps 2, 3, and 4 all in one, because I'm figuring out what my ratio is, or sorry, what my trig function is, and what my ratio is while I kind of put it all in the equation. So from here, my denominator is the variable, so remember I just switched those. X is equal to 7 divided by the tangent of 46. Just type that in your calculator, 7 divided by the tangent of 46. So x is equal to 6.76. In the last one, this is the angle we're looking for. We have the opposite and the hypotenuse. So that's sine that we're going to be using. Then the ratio is the opposite over the hypotenuse. So the opposite is x, the hypotenuse is 19. And from here then just multiply both sides by 19. So again, just type in your calculator, 19 times the sine of 31 gives you 9.79. So the last thing is, this is just kind of a little bit of a heads up of what we're going to get into in the next lesson. So far we've solved for the sides. If you look back on these, we did several different problems. We used sine, we used cosine, we used tangent. Sometimes we had the variable in the numerator, sometimes in the denominator. But every single one of these, we knew what the angle was. We were looking for one of the sides. Well, now what we're going to be solving in the next one is where we don't know what the angle is. So we'll have something like this. It's a right triangle. We don't know what that angle is, but I know this side is 10 and this side is 15. We're going to try to find that angle. Well, to do that, you're going to end up with your angle is the variable. So if you look at this one, we have 3x is equal to this fraction. Well, from here, to get that x by itself, I'm going to divide by 3. I'm going to divide both sides by 3. I know that looks a little bit strange, but the reason we're dividing is because we're taking the inverse. We're taking something that cancels that. So we're taking the inverse, the opposite of multiplying, so we're dividing. So I'm not going to get into it too detailed, but when I have this as my variable, that's what I'm solving for. I need to get rid of this tangent, and I want to take it to the other side. Well, just like the opposite of multiplying is dividing, the opposite of doing the tangent is called the inverse of the tangent. The way we represent that is just an exponent of -1. So we do that on both sides. That cancels out tangent, so we just have the angle left, and we have the inverse tangent of 5/4. A lot of students struggle with this, and I'm going to be honest, I don't actually know why. I think the lesson we just did right now is harder than that because this is just one extra step. And again, from here, you put it in your calculator. If you look at your buttons that say sine, cosine, tangent on your calculator, most of them right above that have sine to the -1, cosine -1, and tangent to the -1. So to type this in your calculator, you just hit your second button or your shift button and then hit tangent, so it has that little -1, and then type in the fraction 5/4 or 5 divided by 4. Either one works. Again, if that doesn't make any sense, that's fine. The big punchline is, and I wasn't even going to go that far, the big punchline is I wanted to make sure I can tell you, hopefully it can sit overnight, that we need to get rid, the next lesson, we'll get rid of this tangent by taking it to the other side, so it cancels. All we have left is the angle. Now to do that, it's that inverse tangent. So we'll talk about that in the next lesson. If you have any questions, make sure you let me know.